All right, 1.5, solving inequalities with one variable in one variable. So we're solving and graphing inequalities. We're going to have one variable. So remember, inequalities are mathematical sentences that shows the relationship between quantities that are not equivalent. These are the ones that have more than one answer. So our open and closed circles and our arrows with our graphs. And then equivalent inequalities are inequalities with the same solutions. Just like equivalent equations have the same answer. All right, so we're going to solve and graph the solution. So this is just like solving equations, but we have a less than or greater than, so we're going to have to graph them because remember there's more than one option. So I'm going to distribute first, get 12x plus 4 plus 6x. Don't forget those double negatives. All right, negative 4 times negative 3 is positive, and negative 4 times negative 1 is also positive. So if I combine like terms, we get 18x plus 4 is greater than or equal to 16. I feel like I need to move already all the way over here because I'm out of room. Too small for my handwriting. So I'm going to subtract 4 just like an equation. 18x greater than or equal to 12. And then I'm going to divide by 18. X is going to be greater than or equal to, I have to reduce by 6, so we're going to get 2/3. Okay, so this is where the graph comes in. So we always put our answer. I'm going to put 1 less and 1 more. So maybe I just put 1 whole, because that's 3/3, and 1/3. Remember, when it's equal to, we have that closed circle, because it means it equals 2/3. Okay, open circle is if it's not equal to. And then I want everything bigger. See, x, everything has to be bigger than 2/3. Well, 1 is bigger than 2/3, so I'm going to point my arrow towards there. Everything bigger than 2/3. All right, let's do number 2. So same thing, just treat it like it is an equation. So I'm going to move my variables together. And I'm going to get 2x plus 19 is greater than or equal to negative 7. Don't lose that negative. And a minus 19. We're going to get 2x is greater than or equal to negative 26. And then I'm going to divide by 2. And we're going to get x is greater than or equal to negative 13. All right, so same thing, put negative 13 in the middle. 1 bigger, 1 smaller, still a closed circle, and still everything greater. All right, let's see, pause, let's have you do this one and see if you can figure out how many solutions for this inequality. All right, so we distribute. We get negative 6x plus 15 greater than negative 6x plus 9. So I add my 6x. And we're going to get 15 is greater than 9. But 15 is always, forever greater than 9. I'm pausing because I'm just going to double check my life right now. I'm going to be honest. Don't want to steer you wrong. Wyatt, I should have had my book open before I did this.
Yeah.
He says, yeah. So this is what's a little different with this, is that when it's always true, 15 is going to always be greater than 9. This is actually our infinite many. Everything's going to work. Okay, because it's true, it's always true, right? 15 is always greater than 9. So everything's going to work. So it doesn't really matter. I can't graph it because everything that's true will work. So this is our infinite, all real, everything will work. All right, so we distribute here. Nope, that's 6. Come on, Wyatt. And then I'm going to subtract. And this time we get negative 5 is less than negative 6. Is that ever true? No. Negative 5 can never be less than negative 6. So if this is not true, we would say this is a no solution. There's nothing I can do to make that true. Okay, so with these, you can't just stop halfway through. With equations, we can stop halfway through because we could see that both sides did not equal each other, or we could see that both sides were perfectly equal to each other. With these, you're going to have to solve them all the way down and see if it's true always or never going to be true. So we can't graph these because what am I going to put on the graph? Nothing. So, all right. Part of my picture is gone. I'm going to move that while you guys are, oh, of course. All tight. There we go. Make it smaller. What is that in my way? All right, you guys work on these problems while I fix my problem, my boxes. Work on 6. Are you working on 6? Are you annoyed by my voice yet? Okay, and then when you get done with 6, do 7. And then when you get done, check your answers. All right, we get 2k plus 8 minus 3k less than or equal to 14. Negative 1k plus 8 less than or equal to 14. Minus 8, negative 1k, I'll put a 1. Less than or equal to, what is that? 6? Why it says yes. Okay, this is the tricky part. You may have to change your answer. We are going to divide by negative 1. But when we divide by negative, we have to flip the sign. So you have to remember that from last year. When we divide by a negative, it's telling me to take the opposite, and it tells me to take the opposite of everything. So when we divide or multiply by a negative to both sides, we have to flip that sign. If you don't, your statement will never be true. Okay, so don't forget that. So then we graph it. So you may have to fix your graph. You probably got negative 6, but you're going to need to probably fix your graph. So it's going to be closed, and now everything needs to be greater than negative 6 because we had to flip that sign. So make sure you make that adjustment, flip that sign. All right, so hopefully you did this one before you unpaused. So I'm going to get 10c minus 15 greater than 0. What?
It's 5.
But 3 times negative 5 is 15. Wyatt's checking me. We're having an argument. But good job for checking me, Wyatt. It's going to be the best video ever, huh? And then we divide by 10. No worries for flipping because it's not a negative, but we are going to reduce and get 3 over 2. All right, I'm going to put my graph over here. So 3 over 2, that's 1.5, so let's just put 2 and 1. This one's going to be open because not equal to. So it starts there, but it can't be that answer. Remember, that's what that means, that it can't be that answer. I still want everything greater than, so we're going to go that way. I don't know why every single problem is a greater than problem, but it is. Oh, yay, our favorite, story problems. Not our favorite. All right. The unit cost for a price of fabric is $4.99 per yard. Per yard, including tax, so they pay for your tax, don't worry. You have $30 to spend on material. How many whole feet of material can you buy? Okay, so we have $4.99 per yard. Okay, X is going to stand for yards. I have $30 to spend. Can I spend more than $30? Can I spend $30? So it's going to be less than or equal to 30. Because I can spend 30, but I can't spend more than 30. Okay, so this is just a one step, makes it pretty easy. We're going to divide by $4.99. Oh, I don't know why I'm running 30. We gotta figure out what $4.99 divided by 30 is. Uh-oh, my microphone died. Uh-oh. Now I'm just gonna yell. So $4.99, nope, 30 divided by $4.99. It's a crazy repeating decimal. Hopefully you guys can hear me. It's 6,012 da 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 da. Okay? But it says to the whole yard. So am I gonna round up or round down? If I round up, it's gonna be 7, and I don't have enough for 7. I only have enough for 6 and a little tiny bit more. So we're gonna round down and say less than or equal to 6 yards. Because this is real life too. Who am I gonna ask to get me 12 thousandths of a yard? When you go buy yards of fabric, you don't ask for tiny bits. You either say full yards or part of yards, right? Like a half a yard. But you don't ask for these itty bitty bits. Okay, so we're gonna round down. All right, here is your independent practice. It is also a story problem, but now you're comparing the two and figuring out which one is least expensive. And so you're going to solve 2 different inequalities and figure out which one's going to be best for you for less. This is going to be called less. All right? All right. Until next time.